We have a long one. Hello, today we're going to integrate the quadratic formula. And my pen refuses to work. Go off. 1 over ax squared plus bx plus c dx. Well, let's just jump into it. So, first things first, let's factor out the a. It's going to be 1 over a. This is going to be following us to the entire solution. X squared plus b over ax plus c over a dx. Well, next step is we're going to complete the square for this little buddy to ease up for us. Let me just switch pens to another color. So we're gonna get the term that's with x, b over a, multiply it by 1 over 2, then squared to be the other factor that we're going to add. This is just going to be b squared over 4a squared. Nothing really out of the usual. We just see if you can. I'll just give it a little zoom to help you to see this more clearly. Yes, I just have to keep in my mind that I have to do this because my camera angle is not that big. My phone is kind of old. X squared plus b over ax plus b squared over 4a squared minus b squared over 4a squared, because we cannot change anything. This is just helping us. C over a. This is just x plus this, b over 2a squared minus b squared over 4a plus c over a. Sorry if I'm going too fast, it's just today we're going to have a big one, so to fit it all I have to be faster. This thing, we just for getting it simpler, x plus b over a squared plus, well, this when we add is going to be 4ac minus b squared over 4a squared. Oh, sorry, I forgot to put the a squared here. So I think that we have to realize that this will be a nightmare to keep writing and writing and writing. And there's another thing about this number. It can be either positive if this term is bigger than this, or this can be, so there are three cases where this, well, we just name this thing. I'll change the color just to help with the contrast and just to help the substitution. This thing right here, we're going to call it D. And there are three cases. Of course, for all numbers, D is bigger, smaller, or equal to 0. So assuming D bigger than 0, we'll just call this D. We have the integral of 1 over a times, please forgive my neighbors, they're insufferable sometimes, b over, oh, sorry, again, this is the 2, I always have this copying error, x plus 2a squared plus d dx. So this is, well, just doing a simple u substitution, 1 over a at u equal to x plus b over 2a du is equal to dx, just to make it easier for us, to 1 over u squared plus d du. Well, this is the good and old formula that we have for the, well, this is just the inverse tangent of something. We have a formula that we generally use for this. I'm just going to get here. Sorry for. So this is going to just be equal to b 1 over this thing. Well, this is square root of d. This square root of d squared. So it's going to be 1 over 8. It's, of course, as you multiply everything, is 1 over the square root of d inverse tangent of u, in this case, over a. It's just, well, I'm sorry, not a, d, the square root of d, in the case. Sorry, just plus the constant, referring this back to 1 over a root d, tangent, inverse tangent of x plus b over 2a over root d plus c. Well, first case is done. Second case is even easier. This is the first. Oh, sorry, you were seeing the final bits, but that's all that we did. So now we have the second case, d equals 0. In the case of d is equal to 0, it's going to be fairly easy. Just get the original one. Oh, since we add d, in this case we won't have to add d because it's just 0. So it's 1 over x plus b over 2a squared dx. Oh, this is, well, 1 u substitution. U is equal to x plus b over 2a du is equal to dx again. So it's just 1 over a integral of, well, let me just u to the minus 2 du, because it's 1 over u, just make the process a little bit easier. Well, we add 1 and just revert it back, while adding 1 to our original term. So it's just the 1 over a times the negative 1 over u plus c. And this thing is nothing but 1 over a times 1 over negative, sorry, x plus b over 2a plus c. Just to make it neater, this minus, well, this a was just going to cancel also, it's just 1 over the a is ax plus b plus the constant of integration. This is it's fairly easier to show everything. I'm sorry if I just keep, because it's hard for me to get a perspective. Okay, I have to choose between looking at the camera and looking at the solution. If the solution is wrong, the video fails. And this, and you're not seeing, it still fails. So I have to keep. I'm still learning. D is smaller than 0. This is our last case. Well, this is going to be a little less. Oh, sorry. 1 over a times the integral of. Well, since d is smaller than 0, it's negative. So x plus b over 2a. B is over 2 here, because just minus d dx. Oh, sorry, I forgot to square it. As you can see, I have a bad habit of forgetting some small parts. Just for convenience, as always, u is equal to x plus b over 2a. du is equal to dx. So it's just going to be 1 over a times the integral of 1 over u squared minus d du. So this is a form that we can do partial fractions with. We can just break this down to something simpler and work from there. Just get my notes closer to me to avoid getting something wrong. We can, well, this is still, we do this right here, 1 over u squared minus d. This is just the difference of two squares. This is just root d, but squared. So it's going to be equal to 1 over u plus root d. No, sorry, not 1. A plus b over u minus root d. So now we can just multiply by this to get 1 is equal to a u minus root d plus b, it's just going to simplify it out, u plus root d. Get all the terms that have the constant together. 1 is equal to a u plus b u minus a root d plus b root d. So there's nothing that has u in this side, so it's just a plus b is just equal to 0, and this number is equal to this two numbers, minus a root d plus b root d is equal to 1. And this is our system of equations to solve. This is very, well, we just rewrite this term. B is equal to minus a, because if you just put the a to the other side, or if you want to subtract a in both sides, you get this. So b is equal to negative a. We can put b, this is negative a, we have negative a is equal to b. So b root d plus b root d is equal to 1. we want the value of b. So 2b root d. Sounds funny, 2b root d. So just divide both sides by 2 root d. B is equal to 1 over 2 root d. A is going to be, well, A is negative. So, well, if B is equal to this, A is going to be negative of this. So A is equal to negative 1 over 2 root d. So we have both of these. We can plug them into the original one and factor this term. 1 over 2 root d. A is negative, so it's just going to be negative 1 over u plus root d plus 1 over u minus root d. Oh, sorry, I was just going to add plus c. I'm sorry that well, this is the development. This is a long one, so this is how it turned out. So we'll get back to the original one. It's going to be 1 over a times, well, this is a constant, it's multiplying all of them, so put it in red. 2 root d integral of this thing minus 1 over u plus root d plus 1 over u minus root d du. So 1 over 2a root d. Oh, both of them are very simple. This is going to be minus the ln of the absolute value of u plus root d plus the ln of u minus root d plus c. And this, we can just substitute back the u plus x plus this, so it's going to be 1 over 2a root d of this body right here is going to be minus the ln of the absolute. I'll just subtract this. I just made it worse, didn't I? X plus b over 2a, the square root of d, plus the ln of x plus b over 2a minus root d. And we're just done. Just add the constant, and those are all the three cases. The reason why I'm doing this is just to ease out for us in the future. We just finish this. Oh, it's just finished, but I negative multiply by 2 to get this up and bottom. Just 2 over 2a x plus b plus the constant, just to make it a little bit more bearable to see. So these are the three formulas that we are going to use during our mathematical journey until the integral of 1 over x to the 6th power minus 1. So I hope you enjoyed this. This is going to be one hell of a ride, so please join me. Thank you for watching. Please like, share, and subscribe. And I'll see you next time. Goodbye.